Unbalanced forces are required for objects to have a change in motion. But let's look at specific examples of how this causes a change in speed. It all depends on the amount of force on the object and how much force the object is exerting back. The larger force wins. If the objects are going against each other, the larger force will cause more movement in the direction of that force. Think of a boat on the water. If you row across the river with a greater force than the water is flowing back on you, you will move faster in the direction of the larger force. The sport of rowing, or crew, uses this concept to move across the water very quickly. Instead of the force of just one rower, you can have 8 rowers. This would increase the team's speed quite a bit. The water has a force pushing on the boat, but with all those rowers moving their oars in the same direction, this adds up to a greater force than the water. Crew is a racing sport. The key to this sport is being in sync with your rowing tempo and efficiency in your stroke. One person's job in the boat is to call out the tempo and help keep everyone in sync. Tug of war is another good example of unbalanced forces. The larger force from one team will cause the rope to be pulled towards that force. The forces are unbalanced. Over time, the larger force will cause a change in motion of the rope as it is pulled to one side since the forces are unbalanced. Forces would be examples where there are no changes in movements. Balancing on a beam, waiting to start a race, and waiting at an intersection for the light to turn green before you move. Unbalanced forces would be when you are changing your motion, such as doing a double backflip, winning at tug of war, and rowing your boat across the water. Different forces cause a change in speed, but forces also cause a change in direction. This is very evident in just about any sport you can think of. In football, it's easy to see. A football player is running with the ball and runs into another player from the other team. He gets tackled and can't keep moving forward. This results in a change of direction due to unbalanced forces. In tennis, the ball sails over the net. The player swings the racket to hit the ball and causes it to change direction, sailing back across the net again. The unbalanced forces cause the change in direction. In soccer, a player kicks the ball to redirect it to another teammate. If they can pass the ball without it getting blocked by the other team, they can direct it into the net to score a goal. The unbalanced forces cause the change in direction, moving the ball from one player to the other. In baseball, a batter hits the ball and sends it over the right field fence. Home run! The unbalanced force caused a change in direction of motion. Remember that the forces are unbalanced. One force is greater than the other. This can lead to a change in direction of motion. Sports are all about movement. A change in direction is caused by unbalanced forces. A change in speed is also caused by unbalanced forces. Sometimes a change in direction or speed can be seen if a force is much larger than an opposing force. You can tell when a batter is swinging the bat that if he makes contact with the ball, it will travel far. We can diagram these forces too. We can draw the size of a force as a large arrow, which also points in the direction of the force. The International System of Units, or SI unit for force, is the Newton, named after Isaac Newton, who spent his career studying motion and forces. The symbol for the Newton is a capital N. Let's explore some basic calculations. If a player moving with a force of 5 newtons going to the right runs against a player running at a force of 2 newtons to the left, we can see that the total force of the two-player system would be 3 newtons to the right. 5 minus 2 equals 3 newtons. Subtract one force from the other if they are going in opposite directions. If two forces are going in the same direction, we can add them together. If the river's water current is moving with a force of 2 newtons, and you are rowing with a force of 3 newtons with the current, the overall force going in that direction is 5 newtons. Or 2 newtons plus 3 newtons equals 5 newtons. If there is a force of an object moving at 5 newtons down and a force of 5 newtons up, these two forces will be balanced. 5 newtons minus 5 newtons equals 0 newtons. If the net force is 0, the forces are balanced and there is no change in motion. A player catches the ball in their mitt and ends the inning. Read the force equations and complete the calculations. Match the correct net forces on the right to their equations on the left.
One force is moving to the right at 10 newtons. An opposite force is 10 newtons. The net force would be 10 minus 10, 0 newtons. One force is 15 going north, while the opposite force is 10 going south. The net force would be 5. 15 minus 10 is 5. One force is going down at 10 newtons, but the upward force is also 10 newtons. The net force would be 10 going down, 10 going up. That would equal a 0 net force, newtons. One force is 100 newtons going east, while there is an additional force of 20 going east. The net force total is 100 plus 20 equals 120 newtons moving east.
Remember that forces are balanced when two forces moving in opposite directions cancel out. If the forces are moving in the same direction, you should add them together. If they are opposite, you should subtract them. Try again. Let's review. When the forces are moving in the same direction, you should add them. 100 plus 20 equals 120 newtons. When the forces are moving in opposite directions, you subtract the forces. 15 minus 10 is 5 newtons. When forces are opposite but equal, the forces are balanced, and the net force is 0. Let's review what we learned. First, we learned that forces can result in a change in motion. Forces can be contact or non-contact forces. Contact forces include pushing and pulling, while non-contact forces act at a distance, like gravity and magnetism. Friction is a contact force that we often forget. Forces are balanced when both forces are equal and moving in opposite directions. Think of a weightlifter holding a barbell steady above their head. Unbalanced forces are what you see most often. These cause a change in motion in your favorite sports. Unbalanced forces cause change in speed and direction. Sometimes they cause both at the same time. We can actually measure the net force by adding up the forces or subtracting them based on their directions. We learned that forces are measured in units called newtons. When the forces are going in different directions, we can subtract them. When they are going in the same direction, we can add them together. And when they are equal in opposite directions, we know the forces are balanced. Next time you play a game or sport, or watch a sporting event, think about the forces. Are they balanced or unbalanced? What is the sum of the forces? Have fun and think of science at the same time. Thank you for using this original tutorial. Be sure to check out our other original tutorials too.